Okay, good evening to you. Today we will see one of the important physical chemistry concept, chemical kinetics. See all of you. Chemical kinetics. This is a very important concept for both point of view as well as competitive point of view. I have to understand very carefully. In both point of view, we have weightage from this topic at 8 marks. Out of 8 marks, he is asking one 5 marks question and one 2 marks question is asking and one 1 mark question is asking. Once again, I am telling for competitive is a very important topic and very easiest and very small topic also, but not observe very carefully. First of all, what is the meaning of chemical kinetics? I think you have some idea regarding kinetics or kinematics. It is nothing but related to speed, velocity. These things we will be discussing under chemistry. See, first of all, chemical kinetics is the branch of physical chemistry. Branch of physical chemistry. Physical chemistry. See, first of all, today we will discuss some introduction regarding this one. So, under physical chemistry in first year, we learned already some topics. What are those topics in first year under physical chemistry? Like chemical equilibrium, thermodynamics, states of matter, all will be coming. So, one of the first year topic physical chemistry is nothing but chemical equilibrium. Here, an important bit is coming. We have to discuss very carefully. Chemical equilibrium studies about reversible reactions. It will give the information regarding the reversible reactions, and also it will explain the factors effects on it. Factors effects on it. These things we are discussing under first year physical chemistry. Nothing but chemical equilibrium. One more topic under first year of physical chemistry is a very important thing, is nothing but thermodynamics. Thermodynamics. Yes. From this only is asking important bit in competitive. What is the importance or what is the use of thermodynamics? Thermodynamics will explain the feasibility of the reaction. Feasibility of reaction. What is the meaning of feasibility of reaction? Possibility of the reaction means whether you taken a reaction or a chemical reaction. The chemical reaction will proceed or not at given conditions. At given conditions is explained by thermodynamics. What is the meaning of reaction will proceed or not at given condition? For example, in the lab we are doing so many experiments. They are giving result, means they are giving products, means at the room conditions those all reactions will be proceeding. Okay, whether it is proceeding or not can be predicted by using the thermodynamics. You see, for example, you take a coal, you want to burn it. Is it happening at room temperature? No. If you want to burn the coal, compulsory you have to use matchstick, or you have to use Bunsen burner. Then only coal will be burning. Means the burning of coal requires some special conditions that can be studied by using thermodynamics. Okay, now same thing we are discussing under second year physical chemistry. Already we learned 2 lessons under physical chemistry: solid state, solutions. And one more is nothing but our topic is nothing but chemical kinetics. Chemical kinetics. So what is the means? It is explaining which things regarding chemical reaction. It will explain about the rate of reaction. Rate of reaction denoted by small r. In our words, rate is nothing but it is indirectly nothing but speed. Speed of reaction is explained or discussed under chemical kinetics, and factors effects on rate of reaction. These things we are discussing under chemical kinetics. Chemical kinetics is the branch of physical chemistry. There we are discussing about the rate of reaction. It is nothing but speed of the reaction denoted by R, and also we are discussing about the factors effects on rate of reaction. We are discussing all these things. Okay. Before going to discussing, once again I am telling here one important bit. What is the use of thermodynamics? Thermodynamics only explains the feasibility of the reaction, means at the given condition whether the reaction will proceed or not. It won't discuss anything regarding speed of the reaction, but speed of the reaction is only explained or discussed under chemical kinetics. Now we are discussing types of reactions. Types of reactions. Okay, anybody? We are classifying the reactions into three categories based on speed of the reaction. Speed, don't use speed under chemistry. Instead of speed, you have to use only rate of reaction based on rate of reaction. Based on rate of reaction, we have three types of the chemical reactions we are discussing. First of all, we have to discuss about the slow reactions. What is the meaning of slow reactions? Is a chemical reaction which takes place by taking more than days time. Means the reaction will not be proceeding fast. Means if it want to take place, it will take days of time. That's calling as a slow reaction. Can you give one example? Rusting of iron. Rusting of iron. Yes, if you observe in our daily life, you take an iron rod, fresh iron rod. Is it forming rusting iron within fraction of seconds or minutes? It will take time, and nearly 15 days, 20 days. After 15 days, 20 days, we can feel rust on it. The spark is going very slowly. Such reactions is calling as slow reactions. Best example, rusting of iron. I will write chemical equation for this. Iron will be combined with atmospheric oxygen and moist. It will becoming dry stuff, ferric oxide, Fe3O4. So we are taking Fe2O3. Sorry, Fe2O3. Here oxidation number will be coming plus 3. Here oxidation number will be 0. Then we have to take here 4 moles, here 3 moles. Then we are getting 2 moles. This is only nothing but the rust formula. It is calling as ferric oxide. Anyway, is going by taking days of time, so is calling as slow reaction. Another category, it is nothing but fast reactions. What is the meaning of fast reaction? The reactions which takes place within a fraction of seconds. Within fraction of seconds, those reactions is calling as fast reactions. Can we give some example? What experiments we are doing in the lab, within fraction of seconds we are observing the products like a precipitate or something. So that's why we are calling them as fast reaction. I will give you some example for fast reaction. It is nothing but all ionic reactions. Ionic reactions are very fast. Already we studied in chemical bonding. What? For example, you take one acid, one base, and one acid. What happening here? Already they are in the form of Na plus OH minus and H plus and Cl minus. They are already in the form of ions in those solutions. Automatically recombination will be happening. Then how it is that one? It is becoming like NaCl plus water. This is happening just after mixing. We are getting the products. That's why it's calling as a fast reaction. And can we give some other example for this one? If you take for example all precipitate reactions. This one also we are using in lab for a detection of chloride ion. What you are doing in chloride ion? You are taking for example NaCl. So that you are adding ammonical silver nitrate solution. We are adding this calling as a tolerance phase. We are adding AgCl. We are adding AgNO3. We are adding. After that, what happening? You know, Ag and Cl will becoming like AgCl. It is becoming like white precipitate, downward aroma white precipitate. And remaining is what? Sodium nitrate. And can I give one more example for fast reaction? Explosive. You take any bomb, just you supply heat energy, immediately burst. That's why we can tell all explosive reactions. All explosive reactions is also under fast reaction. I will give you one example for this one. For example, you take ammonium nitrite or ammonium nitrate. It is becoming like how N2O plus 2H2. Just by supplying heat energy, the chemical will be caused, means undergoing combustion. We are getting nitrous oxide as well as watch what you are getting. Anyway, it is also fast reaction. But what is the another category is very important to us is nothing but moderate reactions. What is the meaning of moderate reactions? Is not going very fast, not going very slowly. Moderate going means the reactions will be takes place in minutes. The reactions will be takes place in minutes. Means general example, all covalent reactions. All covalent reactions will undergo some moderate reaction. Why? Because covalent compound means that covalent bond will be there. They have to break down and they have to reform. It will take time, that too in minutes. That's why those reactions is calling as a moderate reactions. Can I give some example for this one? For example, N2 plus O2 gives rise to 2NO. Now you take the covalent bond having compound N2 plus 3H2 gives rise to 2NH3. If you take H2 plus Cl2 gives rise to 2HCl. All are covalent compound involving reactions, thus they are calling as covalent reactions. Here what happening, bond will be breakdown and bond has to be formed up. These all things will be happening within minutes. That's why they are calling as a moderate reaction. Here one important bit is coming. Chemical kinetics is applicable for all or anyone and why. Means if you want to identify the chemical kinetics means nothing but speed of reaction. Is it possible in slow reaction? No. Why? You are taking lot of time. What happens? So many changes is coming in that reaction condition. That's why we can't apply for slow reactions and chemical kinetics can't applicable for the fast reaction. Why? To find out the speed is going very fast. It's highly impossible. But to whom we can apply, you can identify the means chemical kinetics is nothing but moderate reaction. Means chemical kinetics or speeds of reactions we are discussing in only which reactions? Moderate reactions. This is the one of the important point. Chemical kinetics will not work out in slow reaction as well as fast reaction, but only work out in case of moderate reaction. Why? Because it's not going fast, not going very slow. It's going moderate speed like minutes. That's why we can measure whatever we want. It's possible. That's why chemical kinetics we can apply only for moderate reaction. All of you clear? Yes. Okay. So finally we got one conclusion. The chemical kinetics is only available for the moderate reactions because it's not going very fast, not going very slowly, going with moderate speed means takes place in minutes. So have to remember. Now, first of all, how to discuss under this concept is nothing but rate of reaction. Rate of reaction. From here, concept is starting. Observe very carefully. Rate of reaction is denoted by small r. Indirect is nothing but the speed of chemical reaction. For this, imagine one chemical reaction. Reactants are converting into products. First, see the concept, later we can go to the definition. Okay, first of all, initially means what? At the starting, what we have? Only reactants we have. Why? Because the reaction not yet started. For example, we have 5 molar of reactant. Initially we have any products? No, 0. Yes, you started reaction. What happening? The reactants are consuming the reaction and slowly they are converting into the products. Means as the reaction is proceeding, what happening? For example, after 2 minutes duration, I observed nothing but after 2 minutes taken as a final situation. At final situation, what changes will come in those concentration of the reactants and products? Anybody? What happening? Reactants are slowly converting into products. Means what? Reactants are consuming in the reaction. Consuming in the reaction means its quantity will be decreasing. For example, I find out 3 molar of reactant. Then how many molar of products will form in this reaction? Yes, you see, very good. What happening here? 1 mole of reactant is giving 1 mole of product. Why? Because coefficients only can be considered as moles. Okay, you see carefully from 5 to 3 means how much loss or consumption? 2 moles. The 2 moles only will be appears as a product after 2 minutes. Got my point? Yes. Okay, in this reaction, as the time is going on, what happening? Concentration of the reactant will be going on increasing or decreasing? Decreasing. Concentration can be represented by writing a square bracket in chemical equilibrium already we learned. As the reaction is proceeding, concentration of the products will be going on increasing or decreasing? Increasing. This is common for all chemical reactions. In every chemical reaction, initially we have only reactant, initially products will be 0. After sorting the reaction, slowly the reactant will be converting into products. That's why after some time, concentration of the reactant will be decreasing, concentration of the products will be increasing. Now, we have to discuss about the rate of reaction definition. Important 2 marks question or 1 mark question. Rate of reaction is nothing but change in concentration of reactants or products in unit time. In unit time. Indirectly nothing but speed. Speed means what? Change in concentration per unit time is calling as rate of reaction is calling as speed of reaction. That's what I am telling once again. See? Change in concentration of reactants or products in unit time is calling as a rate of reaction. Nothing but speed of reaction. See, rate of reaction can be expressed with respect to reactant and also products. That is only change in concentration of reactant by what has to be taken? Time change. Time change is nothing but time interval. Observe concept carefully. Time interval. Or also we can express with respect to product. Is nothing but change in concentration of the product by what is coming? Time interval is coming. Time interval. Okay, what is the meaning of change in concentration of reactant in this? Change in what? Final minus initial. That's why I am writing here, see carefully. Concentration of the reactant final minus concentration of the reactant initial by. Time change means what? Final time minus initial time. T2 minus T1. Otherwise you can write TF, Ti. Okay, we can express in terms of products also. Change in concentration is what? Concentration of the product final minus concentration of the product initial by time final minus time initial. Yes, do some mathematical calculation here. R is equals to change concentration of the reactant at final stage 3 minus concentration of reactant initially 5 by time change. Time final is how much? After 2 minutes, so initially 0. After 2 minutes, which is nothing but 2 minus 0 is equals to what is the concentration of the product finally? 2. Initially 0 by time finally 2 minutes. Initially 0. Okay, we are getting R is equals to 3 minus 2 by 2 is equals to 2 by 2. Then we are getting R is equals to minus 1 is equals to minus 1. Is it right? Some changes is required. That's what I am telling. So what is saying with respect to reactant or product, if we can calculate the speed should be same. But here quantity will be okay, but the sign is coming different. It should not. Okay, means once again we have to see R means what? Indirectly nothing but speed of reaction. Okay, whatever speed you can take, is it possible to express in negative sign? Should not. 5 meters per second, 10 meters per second, 100 meters per second, like that, whatever speed will be there should be expressed in positive manner only, but here coming sign is negative. To avoid this negative sign, what has to be done? Some changes has to be done in the formula of the rate of reaction with respect to reactant. That what I am doing here. Rate is nothing but minus of what has to be taken? Change in concentration of reactant by time change. Time change. Are you getting or no? Yes. Or nothing but is equals to any changes is required in the production? No, not required. Why? Because already it is a positive term. Then we are getting which one? Change in concentration of product by time change. Okay, then what we are getting, R is equals to minus of change in concentration of reactant typically coming how much? -1 is equals to, already it is 1. Then we are getting R is equals to 1 is equals to 1 means we are getting same. Are you getting? Why I have written minus sign while expressing in terms of reactant? So if you calculate with respect to reactant rate, it is coming in the negative, but it should not be. Why? Rate means speed is always should be which value? Positive value. To get the positive value, whenever you are calculating the rate of reaction in terms of reactant, you should write before it negatives. Okay, from this I will write the final formula. Rate of reaction is equals to minus of change, can be represented by differentiation D of which one? Reactant by change in time is nothing but dt is equals to, with respect to product, change in concentration of the product by what is coming the time change. This is the expression for the rate of reaction for this given reaction. It is defined as change in concentration of reactant in unit time. It's nothing but change in concentration by change in time. With respect to product also same, but whenever you are writing in terms of reactant should be written negative sign to avoid practical problems. All of you clear? Okay. We have to discuss one more thing here, important bit, units of R. What are the units of rate of reaction? Anybody? Units of rate of reaction is what is coming here. R is equals to numerator coming water, concentration time. Denominator is coming which time? What are the units of concentration? Commonly mole per liter by time. Can we simplify this one? Mole liter comes up is nothing but liter inverse, and time also comes up is nothing but time inverse. The same units will be expressed by taking different time, like how time may be seconds, minutes, hours, or years also. That's why it's becoming like mole liter inverse second inverse, or mole liter inverse is nothing but minutes inverse, or we can take time in hours is nothing but mole liter inverse and hours inverse. Here one important bit is there, rate of reaction has a fixed units or a common units will be there, that is nothing but mole liter inverse and time inverse. For all chemical reactions, write down that only. All chemical reactions, for all chemical reactions, rate of reaction units remains same. Remains same. Is it? Yes, it is. You take whatever speed in normal life, meters per second or centimeters per second, like it will be there, but it will be always fixed. It's not depending upon reaction. Yes, if you take two-wheeler or four-wheeler, we are expressing speed will be in same manner. But in chemical reaction also we are expressing rate of reaction only one common unit is nothing but mole liter inverse and time inverse. All of you clear?